In this video, we want to look at completing a t-table with at least 3 points and then graphing for each of these two equations that we have here. If we're going to complete a t-table, we first need to take the equations and solve them for y if they are not already done so. So for this first one, what we need to do in order to solve for y is to subtract 2x from both sides. Subtracting 2x on both sides will allow us to isolate the y, much the same way that we did back in section 2.5 whenever we had formulas. Now, subtracting 2x from both sides gives me the equation y is equal to negative 2x plus 3. Now what we want to do is to make a t-table with at least 3 points, with at least 3 values. So let's go ahead and draw a t-table, and we can pick whatever values of x we want to plug into this guy. Now again, it doesn't matter what values you pick, but you want to pick intelligent choices. A good number to always pick is 0. And since this coefficient here is an integer, you can go ahead and pick 0, 1, and 2 if that makes you happy. You don't have to. You can pick negatives as well. Just pick any 3 points, or any 3 x values that you want, and now let's find those y values. To find those y values, we're going to take the x value and plug it in here and see what we get. So this is negative 2. I'm replacing the x with 0, and then there's the plus 3. So when I do this arithmetic, I come up with 0 plus 3, so my first order pair is 0, 3. When I plug in 1, I just do the exact same thing. Instead of the x, I'm going to replace that by the number 1, and then I'm going to do the arithmetic. Negative 2 times 1, that's negative 2, plus 3, and that's going to give me positive 1. And again, let's plug in positive 2 in place of x. So negative 2 times 2 plus 3 is going to give me negative 4 plus 3, and that's going to give me negative 1. Now, what we're hoping to have here is to have all 3 of these points be on the same line. So let's plot them and see what we have. For the first point, we have 0, 3. So that means 0 on the x, so you don't move left or right, and then up 3. So here is your first point. So this is the point 0, positive 3. The next point is the point 1, 1. So that's 1 on the x, 1 on the y. So here's the point 1, 1. And then finally we have the point 2, negative 1. So that's 2 in the x direction, negative 1 on the y. So here's our point 2, negative 1. Now all we need to do is draw a straight line, which is why we have this nifty ruler. So just make sure everything lines up the right way, and then we just draw a line through these points that we have here. Make sure that you do go all the way from one edge to the other. Now what we've drawn here is only a line segment. So to make it not a line segment and to make it a line, we put the arrows at the end. And this shows that this line continues on forever in both directions. Any point that is on this line is a solution to my original equation, 2x plus y equals 3. Even this point right here, the coordinates for this point are positive 4 and negative 5. If you plug in positive 4 here and negative 5, you'll see that that does equal 3. It does equal 3. So let's come down here and check that. 2 times 4 plus negative 5. Does this equal 3? And very easily we can see that 8 minus 5 does equal 3. So not only do we have these 3 points here that satisfy the equation, but we were able to find a fourth one away from these guys that also works in the original equation. Now let's take a look at this other problem that we have here. In this problem, it's already solved for y, so a lot of work has been done for us. To make a t-table, we really want to think about the values of x that we're going to plug in and what the possible outcomes will be for the y. Plugging in 0 is always a good choice, but look at this. We have a fraction. So we want to be able to work this guy so that we can kind of get rid of this denominator and make the points that we plot easy. Anytime you have a fraction for a coefficient of x, when it's in this form, pick values of x that are multiples of this guy. So 3 is a good choice, 6 would be another good choice, and if you want to, negative 3 would work just as well. When I plug these values in, I have 1/3 times 0 minus 1, and of course that guy is just going to become 0 minus 1, and that equals negative 1. When I plug in 3, 1/3 times 3 minus 1. Now you see why I picked multiples of 3. You can look at this as being 3 over 1. The 3's will cancel to give me a 1. So 1 minus 1 is going to equal 0. So this gives me a nice, great point to plot with no fractions. Finally, when I plug in 6, that's 1/3 times 6 minus 1. Again, look at the 6 as being over 1 if that helps you. 3 goes into 6 twice. 1 times 2 is 2, minus this 1 is just going to give you 1. So here I have 3 points to plot. Let's see what those guys look like. If we did this right, it should form a line. So here's 0, negative 1. Put that guy right here. 0, down 1. Then we have the point 3, 0. So that means 3 in the x direction, 0 in the y. And the third point we have is positive 6, positive 1. And you can see that we have what should be a nice line going through these. So, let's get a ruler out, because we do want to be as accurate as possible. Be accurate as I am accurate. Okay. Make sure you put the arrows at the end. And you can see that you even go through this point and this point here. So this is the point negative 3, negative 2, and this is the point negative 6, negative 3. You can check that back in here and you will see that that is also a point. So 1/3, if I plug in the negative 6, will this guy equal negative 3? So just by doing the arithmetic, 3 is going to go in here, it's going to make that a negative 2. So is negative 2 minus 1 equal to negative 3? Yes. So we found extra points. We know that they check with the original equation. So we have these 3 points from the t-table, extra points to check, and you know that the line that we have drawn here is accurate and it's correct.